Today we are going to discuss about classification of IC engine. So welcome to my YouTube channel Mechanical Engineering Management. So there are so many ways to classify the IC engine according to the types of fuel used, according to number of strokes per cycle, according to thermodynamic cycle, sometimes it is called as the operation cycle, according to method of ignition, according to method of cooling, according to mobility of governing, according to speed of engine, according to number of cylinders, according to arrangement of cylinders, according to fuel supply system, and according to location of valves. Now we are going to discuss these all different ways to classify the IC engine one by one. So let's start from the first. Types of fuel use. So according to the types of fuel use, IC engine is classified in 4 different categories: petrol engine, diesel engine, gas engine and biofuel engine. So let's see one by one. Petrol engine. In this type of engine, petrol is used as a fuel. In diesel engine, in this type of engine, diesel is used as a fuel. So very simple to remember. In petrol engine, petrol is used. In diesel engine, diesel is used as a fuel. Next, in case of gas engine, the gaseous fuel like compressed natural gas, coal gas, biogas, liquid petroleum gas, producer gas is used to operate the engine. In biofuel engine, biofuel vehicles are vehicles with multi-fuel engines capable of running on 2 fuels. On internal combustion engines, one fuel is gasoline or diesel and the other is an alternative fuel such as natural gas, LPG or hydrogen. So nowadays so many vehicles are on biofuel vehicles. One fuel is the main fuel, that can be the gasoline or you can say petrol or diesel, and the other is an alternate fuel such as CNG, LPG or hydrogen. Next, according to the number of strokes per cycle, IC engine is classified in 2 categories: 4-stroke engine and 2-stroke engine. In 4-stroke engine, one cycle is completed in 4 strokes, means upstroke and downstroke of the piston or 2 revolution of the crankshaft. So look at this figure. So here this piston is up and down and that is called as the stroke of the piston. So there are 4 strokes: suction, compression, power and exhaust. So look at this diagram. So this is the suction stroke, then compression stroke, and then power stroke, and then exhaust stroke. So piston is moved up and down 4 times, and so that it is called as the 4-stroke engine. So in short we can say these 4 strokes complete during one cycle. Now in 2-stroke engine, in this type of engine, one cycle is completed in 2 strokes, upstroke and downstroke of the piston or 1 revolution of the crankshaft. So look at this figure, 2-stroke engine. So in 2-stroke engine, the piston movement is only 2 times during the cycle. So in short we can say during upward motion of the piston, these 2 strokes are parallelly performed, and during downward movement of the piston, these 2 strokes are performed parallelly. So simply we can say in 4-stroke engine, the piston movement 4 times during one cycle, whereas in 2-stroke engine, piston movements are only 2 times during one complete cycle. Next, according to thermodynamic cycle, IC engine classified in 3 different categories: Otto cycle, diesel cycle and dual cycle. So in Otto cycle, the combustion of fuel takes place at constant volume. Generally, petrol engine works on Otto cycle. So this is the figure of the Otto cycle on PV diagram, and here you can see the heat addition. That means we can say fuel takes place at constant volume in case of Otto cycle. Now next, in case of diesel cycle, the combustion of fuel takes place at constant pressure. Ideal diesel engine works on diesel cycle. So look at this figure of the diesel cycle on PV diagram. The heat addition means fuel takes place at constant pressure in case of diesel cycle. Next, third one, dual cycle. In this type of engine, some part of the heat is taken at constant volume and the remaining part at constant pressure process. Actual diesel engine works on dual cycle. So look at this figure of the dual cycle on PV diagram. So fuel takes place at constant volume and the remaining part at constant pressure. So keep in mind that in case of Otto cycle, the fuel takes place, or you can say heat addition, that is at constant volume. In diesel cycle, heat addition takes place at constant pressure, whereas in dual cycle, heat addition takes place at constant volume as well as at constant pressure. Next, according to method of ignition, ICE engines are classified in two categories, SI engine and CI engine. SI engine, that means spark ignition engine. Generally, gasoline engine or you can say petrol engine is based on spark ignition engine. CI engine, that means compression ignition engine. Generally, diesel engine is based on compression ignition engine. So simply you can say from this figure, in spark ignition engine, spark plug is used to ignite the fuel, whereas in case of diesel engine, fuel injector is used to supply the diesel at high pressure. So in case of petrol engine, a mixture of fuel and air is entered in cylinder during suction stroke, whereas in case of diesel engine, fuel is injected into the engine cylinder at the end of the compression stroke through the fuel injector. Spark plug is used to ignite the fuel in case of spark ignition engine, whereas in case of the diesel engine, self-ignition of fuel takes place at the end of the compression stroke. Next, according to method of cooling, ICE engines are classified in two categories, air-cooled engine and water-cooled engine. In air-cooled engine, cooling of the engine cylinder is done by air. In this case, fins are provided on the cylinder, mainly used for light vehicles like scooter, motorcycle, etc. In case of water-cooled engine, cooling of the engine cylinder done by water circulated by a radiator and water pump, mainly used for heavy vehicles like car, bus, trucks, etc. So very simple, in air-cooled engine, the cooling of engine cylinder is done by air, whereas in water-cooled engine, cooling of engine cylinder done by water. So look at these two figures, and these both are air-cooled engine, and here fins are provided on the cylinder in case of air-cooled engine. This is also the same air-cooled engine figure. Here these are the fins. This is the water-cooled engine. Here this water is circulated in the radiator through the water pump, and so that the engine cylinder is cooled by the water. Next, according to mobility of governing, there are three different categories: quantity governing, quality governing, heat and mist governing. In quality governing, the air-fuel ratio of the mixture is kept constant, but the quantity of mixture supplied to the engine cylinder is varied by means of throttle valve, which is regulated by the centrifugal governor. That type of the governing system is generally used in petrol engine. So here, very important point, in quantity governing, quantity of mixture that is governed by means of centrifugal governor. Now in second category, quality governing, a control valve is fitted in the fuel delivery pipe which control the quality of fuel to be mixed in the charge. So quality of charge is regulated by movement of control valve. Example, diesel engine. So simply name itself indicate the quality is regulated by movement of control valve. And quality, that means what? Air fuel ratio. So in quality governing, air fuel ratio is not kept as constant, but it is regulated by movement of control valve. Third one, in heat and miss governing, whenever the engine starts running at higher speed, due to decreased load, some explosions are omitted or miss. This is done with the help of centrifugal governor. Example, ICE engines of smaller capacity of gas engine. So very simple, heat and miss, that means on and off of the engine. Next, according to speed of engine, low speed engine, medium speed engine, high speed engine. The crankshaft speed of the engine is less than 100 rpm, then it is called as low speed engine. Example, diesel engine. Medium speed engine, the crankshaft speed of the engine is in between 100 to 250 rpm. They are used in large electrical generators, ship propulsions, etc. High speed engine, here the crankshaft speed of the engine is more than 250 rpm. Example, petrol engine. You need to remember, up to 100 rpm is called as low speed engine, more than 250 rpm is called as high speed engine, and in between 100 to 250 is called as medium speed engine. Next, according to number of cylinders, single cylinder engine, multi-cylinder engine. Here only one cylinder is present as shown in figure A. The power generated in power stroke is used for functioning of other strokes of the engine. So here you can see this is the single cylinder engine. So very simple, name itself indicate only one cylinder is present. Multi-cylinder engine, here more than one cylinder are present as shown in figure B. As per firing order, the power strokes takes place in the respective cylinder. So look at this figure, 1, 2, 3, 4. So 4 cylinders are there, and according to the firing order, the power strokes takes place in the respective cylinder. So very simple, in single cylinder engine, single cylinder is used. In multi-cylinder engine, multi-cylinders are used. Next, according to arrangement of cylinders, horizontal engine, vertical engine, V-type engine, inline engine, radial engine, opposed piston engine, opposed cylinder engine. So start from first, horizontal engine. So here you can see the piston cylinders are in horizontal position. That's why it is called as the horizontal engine. Vertical engine, piston cylinder are in vertical position. That's why it is called as vertical engine. Third, V-type. Here you can see the arrangement of the cylinder are in V shape, and so that it is called as V-type engine. Next, inline engine. So this is called as inline engine also, where all the engines are in the same line. That's why it is called as the inline engine. Radial engine. The cylinders are in the radial direction. That's why it is called as the radial engine. Next, opposed piston engine. So look at this figure. In opposed piston engine, only one cylinder is used, in which two pistons are reciprocating in opposite direction. That's why it is called as opposed piston engine. Next, opposed cylinder engine. So here you can see the cylinder are in opposite direction. That means both are at 180 degree to each other, and so that it is called as the opposed cylinder engine. Next, according to fuel supply system, ICE engines are classified in 3 different categories: carburetor, airless injection, air injection. In carbureted engines, the fuel-air mixture meets in the carburetor. The mixture then goes to each cylinder through intakes. In airless injection method, the fuel under high pressure is directly injected into the combustion chamber. Whereas air injection method is generally used in the large stationary and marine engines. In this method, first air is compressed through a high pressure, then a blast of air is injected into the cylinder along with the fuel. So very simple, in carbureted engine, the fuel air mixture meets in the carburetor first and then it is supplied to the cylinder. In airless injection method, the fuel under high pressure is directly injected into the combustion chamber. So here high pressure air is not used. Whereas in case of air injection method, air is compressed first and then a blast of air is injected into the cylinder along with the fuel. Next, according to location of valves, overhead valve engine, side valve engine. An overhead valve engine whose valves are located in the cylinder head above the combustion chamber. So here you can see these are the two valves and this is the combustion chamber. So these two valves are located in the cylinder head, that is above the combustion chamber. So here you can see in this figure, the valves are located in the cylinder head above the combustion chamber. A side valve engine whose valves are located within the engine block instead of in the cylinder head. So here you can see valves are located in the side of the engine cylinder and that's why it is called as the side valve engine. Look at the another figure. Here this is the engine cylinder and valves are located not above the combustion chamber but it is in the side position and that's why it is called as the side valve engine. So thanks my dear friends, press the like button to appreciate this video.